This lesson is on section 1.1 in geometry, which is about patterns and inductive reasoning. There are two kinds of reasoning that we are going to talk about throughout this school year. One is called inductive reasoning and the other is called deductive reasoning. Both of those you will have to use in the real world. Both of those you have used already. Inductive reasoning is when you form a conclusion based on patterns that you see. That conclusion that you come to is called a conjecture. So an example would be anything that you notice, well, this happens and then this happens and then this happens, and so when you look at that and you see or you come to some conclusion about what you think is going to happen next, that's using inductive reasoning. An example here, you're shopping in a catalog. Shipping and handling for one item is $4, two items $5, three items $6. So you make a conjecture that says that the price for 4 items then would be $7. Not all conjectures are true. Sometimes a pattern that you think you see isn't necessarily a pattern that continues. It might follow for a couple of times but then fall off. I'm sure you've seen that when you've done patterns in groups of numbers. You know, you think, oh, the pattern is adding 7 each time or multiplying by 2 each time, and it really isn't. It's something a little bit different than that. If you can find an example that shows that a conjecture is false, then that's called a counterexample. An example here says the fraction 2 over 1 is greater than the fraction 1 over 2. That's true. The fraction 3 over 1 is greater than the fraction 1 over 3. That's true. 4 over 1 is greater than 1 over 4. Those are all true. So if I make the conjecture that says a whole number is always greater than its reciprocal, okay, so anytime I take a whole number and put it over 1, it's going to be bigger than if I flip that fraction. So a counterexample to that would be something that when I flip it, the first one is not greater than the second one. A good example of that would be the number 1. If I take 1 over 1, it is not greater than 1 over 1 when I flip it. That would be a counterexample. The number 1 is a counterexample. It proves that my conjecture that all whole numbers are greater than the reciprocal is false. Okay? So those are the 3 words that we're going to use in this section. Inductive reasoning, basing a conclusion on patterns. A conjecture would be that conclusion. And a counterexample would be something that proves that our conclusion, our conjecture, is false. A few examples of homework problems that you might see are find the pattern. Tell me what's the pattern that takes you from this number to this number and then to this one and then to this one, and then give me the next 2 terms in the sequence. To do that, you're going to look at what's the relationship. What's the relationship between this one and this one? What's the relationship between this one and this one? What's the relationship between this one and this one? Sometimes it's easier not to start with the bigger numbers or the first numbers. Sometimes it's easier to start with small ones. I recognize that 96 is twice as big as 48. So to get from 96 to 48, I know that I had to take half of it or divide by 2. Well, now wait a minute. How does that continue? Is 96 half of 192? So you have to figure that out mathematically. 192 divided by 2 is indeed 96. So it is half. And so on. And it turns out to be that 384 is twice as big as 192. So the pattern is that you're taking half of the number or dividing it by 2 to be specific. So it says now to find the next 2 terms in the sequence. So if I take 48 and I take half of that, it would be 24. And then if I take half of that, it would be 12. So my next 2 terms would be 24 and 12. my pattern would be that I'm dividing by 2 or that I'm taking half of it. Another kind of problem you're going to see is, can you find a counterexample for a conjecture or for a conclusion? The conclusion that I've come to is that if a number is divisible by 5, then it's divisible by 10. Okay, that works. For example, 20, the number 20. Number 20 is divisible by 5. It's also divisible by 10. 30. 30 works. 30 is divisible by 5. It's also divisible by 10. These numbers follow the conjecture. But is there a number that doesn't follow the conjecture? Is there a number that's divisible by 5 but not divisible by 10? If there is, then that's a counterexample. And your answer might be anything that ends in 5. Okay? 5 is divisible by 5 but not divisible by 10. 15. 15 is divisible by 5, not divisible by 10. These are counterexamples. Okay, so it says find a counterexample. 5 is a counterexample. 15 is a counterexample. 20 and 30 would be not counterexamples. They're actually showing that it works. All right. That concludes this lesson. Your homework for each of the classes, make sure that you pay attention which class you are in, whether you're in the honors geometry, regular geometry, or the CT geometry. Make sure you do the homework according to your assigned class.